Assalamu alaikum. So we will continue to review and discuss some example and problems about thermodynamic physics. Okay, in this example, a sample of gas expands from 1 meter cube to 4 meter cube. Then it's expand from 1 to 4 meter cube while its pressure decreases from 40 Pascal to 10. How much work is done by the gas if the pressure change with volume via each of the three paths shown in the figure below? Okay, from path A, we know from path A we have this pressure, the work equal 120 جول. Why? The work equal B V في دلتا B. اوكي، لكن عندي pressure 40 في الديفرنس للفوليوم 4 ناقص 1 بيساوي 3 وتساوي 120 جول. Now path B the work equal 75 joule. Okay, this path B. Okay, this and the work is the under area, so we can calculate like this. Path C. Okay, from path C, from this is path C. Okay, this one and this one. This is path C. Here, which equal 0. Why? Because the volume here is constant. Then delta V equals 0. So it remains from 1 to 4, this one. We have the pressure is 10 times delta V 4 ناقص 1 3 وتساوي 30 جول. Okay. Then this is a simple problem. Another example, a cylinder of radius 5 centimeter is kept at pressure with a piston of mass 75 kilogram. What is the pressure inside the cylinder? Okay, B, if the gas expands such that the cylinder rises 20 centimeter, what work was done by the gas? C, what amount of work went into changing the gravitational potential energy of the piston? D, where did the delta X equal 1 2 and B atmosphere equal 1 في 10 القوة 5 باسكال which equal 180 M, and find the pressure of the gas. The pressure of the gas simple تساوي الفورس على الاريا زائد B 80 M وتساوي بهذه الحالة 1.95 في 10 القوة 5 باسكال. Find the work of the gas. The work equal the pressure times delta V. And the work, in this case, the pressure of the gas delta V. delta V هي عبارة عن الاريا مضروبة في delta X وتساوي 180.8 جول. Find the work of gravity. Work of gravity, we know that mgh, and this is equal 88.3 joule. And D, what did the other work go? It's compressing the outside air. Okay, another example. In this figure, we have the pressure graph with the volume in meter cube, and they ask what amount work is performed by the gas in the cycle AFI. Then AFI. Okay, okay. In this case, and also he asked how much heat was inserted into the gas in the cycle. What amount of work is performed by the gas in the cycle BF? In this case, amount of work is the enclosed area. And this enclosed area, the work equal 3 pi. وتساوي 3 في 10 القوة 5. ليش 3؟ عندي أنا من 1 إلى 4، إذا the pressure عندي هون اللي هي راح تكون 3. How much heat? Delta U equal Q minus the work, and delta U equal 0, so the Q equal the work. وتساوي 3 في 10 القوة 5 جول. What's the amount of work performed by the gas in the cycle? BF. الwork بيساوي minus 3 في 10 القوة 5. Why؟ أنا عندي from I to A equal 3 في 10 قوة 5 جول، لكن أصبحت إيش؟ from إيش بده؟ from PF تساوي إيش؟ minus. This is the process like this, and this is what هذا الاتجاه. Okay, reverse. Okay, another example. Consider a monoatomic ideal gas which expands according to the PV diagram. What work was done by the gas from B to C? إذا بده from B to C, and what heat was added to the gas between B and C, and what work was done by the gas from C to A, and what heat was added to the gas from C to A. Simple. Find the work from BC. We know that the work BC تساوي minus the area, and this the area which equal minus 10,000 joule. It's rectangular, so 0.6 minus 0.2, it's 0.4. 0.4 times 25. اوكي، هي عبارة عن المستطيل work under area وتساوي minus 10,000. Find QBC. U تساوي 3 2 PV. First find UB and UC. If UB تساوي 22,500 and UC تساوي 7,500. دلتا U تساوي ناقص 15,000. إذا نوجدها حسب الريليشن العلاقة U تساوي 3 2 PV. What is UB here and what is UC? So delta U تساوي UC minus UB. In this case, finally, we solve for Q about first law of thermodynamics. Delta U تساوي Q minus the work. And in this case, Q تساوي ناقص 10,000 جول. And the work equal ناقص 15. و Q is equal ناقص 25 كيلو جول. Find the work from C to A. From C to A, okay? From C to A, the work AB تساوي 0 جول. Okay. Sorry, the work here is he need from C to A, and this is constant volume, so the work is 0. Find the QC. First, we have to find U at C and then U at A. UC تساوي 7500 جول and UA 22 كيلو جول. إذا دلتا U تساوي 15000 جول. Finally solve for Q وتساوي 15000 جول. Network done by gas in the cycle. We know that work A B C زائد work B C زائد work C A وتساوي 10000 جول. And the amount of heat to gas QAB زائد QBC زائد QCA وتساوي 10000 جول. This don't mean that the engine is 100% efficient. And we will discuss this, the efficient of engine, and the second law of thermodynamics, that we cannot find a device work 100%. Okay, another example. Imagine that we rapidly compress a sample of air whose initial pressure is 10 القوة 5 باسكال and temperature is 22 Celsius to volume that is a quarter of its original volume. Pumping tire مثلا بايك. إذا بدنا نعمل bumping لعجل البسكليت البايك. What is the final temperature? So we have rapid compression, approximately adiabatic, no time for the energy exchange with the environment due to thermal conductivity. Okay. So B2 تساوي B1 في V1 to gamma over V2 to power gamma. And for adiabatic process, we know that T1 في V1 to gamma minus 1 وتساوي 2. T2 في V2 في gamma minus 1 وتساوي constants. So B to power gamma minus 1 over T to power gamma تساوي constant. And we solve for T2. T1 تساوي V1 على V2 في gamma to power gamma minus 1. Finally, we have 514 Kelvin. Okay. Finding the work. An ideal gas with gamma equal 1.4 occupies 4 liter at 300 Kelvin and 100 kilopascal pressure. Okay. It compresses adiabatically. Remember that when we use its expand adiabatically or compress adiabatically, we have to use the previous relation for specific heat at constant pressure, specific heat at constant volume. So to 1/4 of original volume, then cooled at constant V back to 300 Kelvin, and finally allowed to expand isothermal to its original V. How much work done on the gas? Then this is the relation. Okay, so AB adiabatic, we have the work from A to B. So BA في VA ناقص B the B over gamma minus 1. And the relation for the B, if we need the pressure B equal BA في VA over VB to power gamma, and then we substitute the value, and finally we have ناقص 741 جول. BC isochoric or isovolumetric. It's constant volume. So the work is BC equal 0. And CA isothermal. So the work from CA equal NT في لن ال VA على VC. And this is gives BA في VA في لن الأربعة وتساوي 565 جول. work done by the gas. This means a lot of work A, B, and from B, that work from B to C, that the work from C to A. So we substitute the value work from A to B and work from B to C. We know that and work from C to A. النتيجة equal minus 186 جول. Okay. Another example, a thermodynamic system undergoes a process in which its internal energy decreases on the system. Find the energy transferred from it by heat. Delta U equal Q plus the work, and the Q equal delta U minus the work. We know why this minus, because we need the Q, so delta U equal minus the work وتساوي ناقص 701 جول. Note, sign convention for Q. If Q greater than 0, system gains heat from environment. Another example about diesel power. Fuel ignite in diesel engine from the heat compression. No spark plug needed. ما في عندنا شرارة كهربائية. إذن this is the diesel power, okay, engine. Compression is fast enough to be adiabatic. So we have to use, in this case, if the ignition temperature is 500 Celsius, what compression ratio V max over V minimum is needed? Air specific heat ratio is gamma equal 1.4. So we have to use this relation with gamma, specific heat at constant volume, specific heat at constant pressure, when said that adiabatic compression or expanded. And before the compression, the air is 20 Celsius. So TVV to power gamma minus 1 equal constant, and V max to V minimum equal T minimum over T max to 1 over gamma minus 1. We have to arrange this relation that 273 كلفن زائد 500 كلفن على 273 كلفن زائد 20 كلفن. We have to convert it to Kelvin, the Celsius, and النتيجة equal 11. Okay, two cylinders at the same temperature contain the same gas. If B has twice the volume and have the number of moles as A, how does the pressure in B compare with the pressure in A? Okay, when we solve this problem, we can get the results. The pressure at B equal probably be the pressure of A. Another example, a gas cylinder and piston, okay, are covered with heavy insulation. And then we have insulation. The piston is pushed into the cylinder, okay, the final piston to cylinder, compressing the gas. In this process, the gas temperature ايش راح يصير فيه؟ Doesn't change, decrease, increase, ولا there is no sufficient information to tell you. Of course, it will be increase because we compress the piston. Okay, another example, during an isothermal process, 5 joule of heat is removed from the ideal gas. What is change in internal energy? إذن مباشرة isothermal process, this means that the temperature is constant and delta T equals 0, so the change in internal energy delta U equal 0. Okay. Another example, if the gas in container absorbed 300 joule of heat has 100 joule of work done on it, and then does 200 joule of work on its surrounding, what is the increase in the internal energy of the gas? So we solve this problem and we will get 200 joule. Okay, this is the end of this lecture today, and thank you for your attention.